Hello and welcome, my dear grade 9 elite students, to my channel Mathematics Made Easy. In today's session for your math revision, we are going to cover from exam coverage for your coming math term 3 exam from part 2 learning objective 17. So in this session, we are going to talk about transformations and how to use them to write equations from the graph. Let's get started with this video. It's going to be a little long video. Stay with me till the end. Watch the whole video to understand the concept better. So in today's session, we are going to be covering learning objective 17, where you apply compositions of transformations to the graph of functions and use the transformation to write equation from graphs. So in this video, we are covering questions 21 to 26 given on your math book on page 492. So these are the questions that you see, and before we solve each of the question and describe the transformation as it relates to the graph of the parent function, I would like to give you some key concepts for this lesson. This was actually from your book lesson 8.7, where you looked at transformations of functions. So in this lesson, if you have paid attention, then we have used the concept of parent function and the transformation. So we have used actually the equation gx equal to a times fx plus k. So for each of these questions, we are going to compare from these equation and then get to the solution. Remember, in these questions, you just have to describe the transformation. So you have to just say whether it is going to be a translation, whether it's going to be a reflection, whether it's going to be a dilation, or it's going to be a mix of all of these. You don't have to draw the graph. So this is an easy question. You just choose the correct options from the multiple choice which are given to you based on each part and tell what is the transformation. So let me teach you, before we solve this question, the key concept from this lesson, and then we go on to these questions and solve them once again. As I told you in the last slide, the formula or the equation that we are going to use is this one, where fx is going to be the original parent graph and gx is going to be the new or the transformed graph. So this is the key concept. I have taken this from your book, and each constant here in this equation affects the parent graph. So what all constants do you have? Let's highlight the constants. So one value is a, one is h, one is k. So this a, h and k, first you have to find from the given equation. So the question will come in this manner, that you are given already the equation that is after the transformation. You compare that equation with this equation of gx. I'm just putting a star, means you have to learn this equation. It's important. And then after comparing, you will get some value of a, h and k. Based on that value, you have to learn these points and accordingly give your answer. So this value of a will give you what dilation is happening. Dilation means either it will get compressed or it will get stretched. So it dilates the parent graph, and the value of absolute value of a will tell you whether you are going to stretch or compress. Okay, so you have to compare this value of absolute value, whether it is less than 1, more than 1, and accordingly give your answer. Sometimes you'll get a question where the value of a is negative. In that case, reflection is going to happen across the x-axis. The value of h here denotes the horizontal translation. So if this h is positive, the graph is going to go on the right. If it is negative, it's going to go on the left. Value of k denotes your vertical translation. If it is positive, the graph goes up. If it is negative, it comes down. So in general, all of these values of a, h and k affects the graph, and finding these values, you'll be able to say what transformations are happening. So let me explain to you the key concept of transformations of function. So there are 4 kinds of transformation that can come in your exam. Usually there will be a mixed kind of a question, so you always compare with this equation as we saw in the last slide. So it's going to be a dilation based on the value of a. If absolute value of a comes more than 1, the graph would be stretched vertically. However, if the value of absolute value of a is lying between 0 and 1, means less than 1, it's going to be compressed vertically down. So this is how you look at the value of a and decide whether it is going to stretch vertically or compress vertically. Next is reflection. As I told you, if value of A is negative, less than 0, it will open down or it will reflect from the x-axis. So this is x-axis. What is up is coming down. If it is positive, there is no change and the graph is as it is. Then you have horizontal translation, which comes from the value of h. If it is positive, the graph goes h units right. If it is negative, it goes h units left. Then k value will give you the vertical translation. If it is positive, it goes up on the y-axis. If less than 0, goes down. So remember, your horizontal translation happens across the x-axis in the direction left or right, depending on value of h, and your vertical translation goes up and down depending on your value of k. So now that we are ready with the key concept, let's solve the questions one by one. Okay, so now we are ready to solve these questions. I will quickly write again the equation of gx, which is going to be a multiplied with f of x minus h plus k. So let's compare each part. Let's start with 21. So I'm going to compare this equation y equal to minus 6 times absolute value of x minus 4 with y equal to, so gx can be written as y also, not a problem, a times f of x minus h plus k. So let's compare. So if you see, the value of a here is negative. So because it is negative, definitely reflection about x-axis is going to happen. So if we go to this key concept and the table, if a is negative, the graph opens down. So what is up will come down. So this is the first transformation. You just have to describe the transformation. You don't have to do the graph. So value of A being less than 0 tells you reflection. Next, if you take absolute value of this A, it's going to be absolute value of negative 6. Remember, absolute value always gives you positive results. So this is plus 6, which is more than 1. So if absolute value is more than 1, the graph is stretched vertically. So what is the dilation here? This is the second transformation. So you have to select stretched vertically. Okay. Let's come to next one. Now here there is no value of h is 0, and if you compare value of k is going to be negative 4. So if k is negative, this is vertical translation, the graph is going to go down by 4 units. So here if you see, we have completed the question. For this question 21, there are 3 types of transformation. 1, reflection about the x-axis, 2, dilation where you are stretching vertically by a factor of 6, and 3, vertical translation where the graph goes down by 4 units. So this is how you compare the equation and get your answer for this question. Let's do some more questions on the next slide. Question 22 and 23 are quite easy, so let me do now question 24 in a similar way. Again, we are using the same method, so you may try it question 22, 23, 25 and 26 yourself and then check your answers in the next slide. So let's do 24. So first I write the equation which is given, that is this one, and then I write the transformed equation which I compare having a times f of x minus h plus k. So let's find our values of a. A here is 1 by 2, and if you take absolute value, it's going to be still less than 1. So if you go back to your table, if absolute value is less than 1, the graph is compressed vertically down. So the dilation that is going to happen is compressed vertically. This is the first transformation. Second, we have to compare the value of h and k. So if you see, h here is 1 and k here is 14. So h is representing horizontal transformation or translation. So it's happening on the x-axis. So it will move right by 1 unit. If you want to go to the graph and see, this is what is the correct answer. Then k is vertical translation, as you know. So it is positive. So it's going to translate k units up. So up by 14 units. So this is how you solve this question 24, and the 3 correct transformations are these. Similarly, please solve all the remaining questions and then check your answers from the next slide. So now I'm going to show you all the correct answers for question 21 to 26. For question 21, as we saw in the previous slides, that three transformations are happening: reflected along x-axis, stretched vertically, and translated down 4 units. For question 22, the graph is stretched vertically and translated by 11 units. So these are the two transformations. Now, before we go further, let me remind you, in your ministry exam, you will only get the question where you have to describe the transformation. So about this is a question from part 2, means it is going to be multiple choice, so you will select all the correct options. Like this is the first option, reflected in the x-axis; second option, selected vertically; third option, translated down. If you miss any of these options, your answer will give you partially correct marks, not the whole marks. So please, for each one, there is more than one transformation, select all correct answers. Now for 23, the two transformations are compressed vertically and translated down 2 units. For question 24, answer is vertically compressed, translated 1 unit right, and translated up by 14 units. For question 25, 26, we have these answers. So now you can check all your answers, and I hope you found this video useful. If you did, give it a thumbs up, and that brings us to the end of today's session. To the end of today's video, which was based on lesson 8.7, transformations of function. I hope you found the video useful and understood very clearly the questions 21 to 26 that we covered today from learning objective 17. Until then, this is Ms. Ruchika signing off from this video. Don't forget to like, share and subscribe to the channel, and see you in my next video. Bye bye.